Let's have a look at question 5b, which is all about logic gates, and I can guarantee that this is probably the question that will stump most people. When you look at it, it looks intimidating, but they're actually really nice questions once you've got your head around how to break them up and how to solve them. So it says complete the truth table. A truth table is just a table that looks like this, where you have inputs, these are inputs, and outputs. And a truth table simplifies things. Life is complicated, lots of difficult decisions like what flavour ice cream should I have? I don't know, panic. Truth tables mean if you know what the inputs are, you know exactly what the output of the decision is going to be. So how do they work? Well, we have different inputs such as P, Q, R, and we might have an output. So what does an input mean? This might be a switch. It might be from a burglar alarm and a pressure sensor and a moisture sensor or something like that. And the whole of this expression is an output. So it might be set off the fire alarm under these conditions. So how does it work? Well, we've got logic gates, and, or, and not. So we need to understand what each of those are. So first of all, let's look at not. A not gate has one input, let's call it A, and an output, let's call it Z. And we have a truth table for a not gate, where we'll have the input and the output. And the not gate is awkward, as in it always complains. The output is the opposite of the input. The input's 0, the output's 1, and vice versa. That's how you draw it. I remember it as that little dot there is the middle of well, it's a dot which rhymes with not. So we're only looking at R. This is column R. So whatever this is, not R is the opposite. So 1 is the opposite of 0. 0 is the opposite of 1. So it's nice and easy. We just do the opposites. Okay, not R features in this expression. So this column uses this column. But it also uses Q, and Q is this column. So let's look at both of them. How does it use both of them? Well, it uses an OR gate. What is an OR gate? Well, it looks like a rocket going into orbit. That looks like the O of OR, that's how I remember it. It has two inputs, let's call it A and B, and it has one output, let's call it Z. And let's draw a truth table just for an OR gate. So two inputs means four possible combinations of inputs. I'll do them in binary order like this. And it's an OR gate, looks like a rocket going into orbit. And an OR gate means you have to have either or both inputs switched on. So here, neither of the inputs are switched on. I think my pen's run out of battery, that's irritating. So in this case, I haven't got A, I haven't got B, so Z, the output, is going to be off. Here, have I got A or B? Well, yes, I have, I've got B. Here, have I got A or B? Yes, I have, I've got A. Here, have I got A or B? Well, yes, I've got both. So I have got either or both. So that's how that works. So let's look at Q or not R. Well, Q is this column. Not R is this column. So I want to see, have I got a 1 in this column or this column? So yes, I've got a 1 in either. Here, no, I haven't got a 1 in either of those columns. Here I've got a 1 in both. Here I've got a 1 in Q. I've got a 1 in not R. I haven't got a 1 in either column. I've got a 1 in both, and I've got a 1 in the first column. So this looks horrible here, but it's actually not as bad as it looks. I'm sorry, I'm just going to have to do this without my pen. It might take me a little bit longer trying to mash the screen with my finger. There we go. So let's try and break down what this actually means. We're looking at column P, which is this one, and this expression, Q or not R. So that sounds complicated, but it's actually just this column, Q or not R. So we'll simplify it. So we've got two columns, this one and this one, and we're combining it with an AND gate. Let's see if my pen is charged enough. Let's see. An AND gate looks like the D of AND. And it has two inputs, like an OR gate, but this time you need both of them. So let's write down a truth table for an AND gate. Oops, I wrote a Z. Normally you write like A, B, and Q, but Q is one of our inputs here. It doesn't really matter what it's called, as long as you know if it's an input or an output. Sorry, both inputs off, B on, A on, both on. So for an AND gate, I need A and B for my output to be on. So the only time when the output is switched on is if I have both inputs switched on down here. So with that in mind, I'm looking for a time when column P, that's this column,